皆さん、こんにちは。Good afternoon. I want to thank you each week. Give us a special invitation. I also wanted to thank you, KTTI, playing my video just a little bit. My name is Tom. I'm the Senior VP of Technology at SuperMicro. Although SuperMicro is a US-based company, headquartered in San Jose, but inside Taiwan desu. So we have tremendous investment in Taiwan. We have an R&D center in Taipei, and we also have a sizable manufacturing facility in Taoyuan. In Japan, we also have Tokyo branch office. Actually today, our country manager, James-san, onegaishimasu. So we are here to help this market. Today, I'd like to talk about 5G a little bit. Everybody think about 5G. It's a very, very bright future. But there are some downsides when we advance the technology in telecommunication. Just recently, last month, we have an announcement. This is a GSMA announcement. I'm sure everybody knows what is a GSM. And this is a global system for mobile communication association. And there are more than 50 operators in the world join this initiative. This initiative is about climate change situation, and we want to have some action to fix the problems. And I know KDDI, NTT, Rakuten, everybody in Japan, operator and carrier, are a part of this action. So one of the things they mentioned is that in 2050, we want the world have zero green gas emission, which is zero CO2. That means no more burning fossil fuel, no more burning coal or gas. It's all usable energy. So it's a very difficult, challenging goal. And the goal is trying to limit the global warming to 1.5 degrees C in 2050. It's not easy, but in the world, everybody come together trying to make it happen. This is a guidance for reducing emission and driving energy efficiency, especially in the telecommunication world. We're talking about 130 watts per year we consume because of the telecommunication. This kind of power consumption can power one country. Right? So you can imagine how much power needed for this telecommunication world. And this will contribute 110 megatons CO2 emit to the atmosphere. So that's why it creates some global warming situation, right? On the bottom side is one of the telecommunication company, Vodafone. You can see 99% of the energy consumption is coming from the base station, the telecommunication center, in the central offices, things like that. So once we know where the power consumption is the most, we can try to reduce it. Let's talk about 5G first a little bit. The situation I just mentioned is today, which is a 4G, 3G situation. But 5G, we're going to make it more complicated situation. On the top, 5G core technology that would including the millimeter wave, small cell, things like that. So which means the distance become very, very short. In the future, everybody going to have, no matter where you are, maybe 20 meter or 50 meter, you will see a base station antenna for 5G. which means there will be a lot of 5G equipment in the world consuming power. In the bottom side is a back-to-back technology, which is an enabling technology we're talking about. That including software-defined, everything virtualized, open RAM, right? And also cloud-native 5G, and also mobile edge computing. What does it mean, software-defined? That means everything become commodity, commercially available hardware, which is x86 by software-defined. And cloud-native means end-to-end has to be cloud-associated. So when you do the software implementation, that will realize anywhere, anytime you can access the cloud information. And of course, edge computing is important because end device and cloud is too far. You got to have something in between. Okay. Now with that, you can imagine in the 5G world, how many devices compared to today's, maybe 100 times more. And all the 100 times more devices consuming powers, right? So, in one hand, we are happy because from the systems builder point of view, we had tremendous opportunity. This is one of the typical metropolitan area. You can have maybe millions of base stations. You can have thousands of DU, CU, core computing, and you have hundreds of edge computing, and you have tens of mega data center. Mega data center means easily consume megawatts in a data center, okay? But on the other hand, that will increase the global warming situation, right, if you think about that. So of course in SuperMicro, as I mentioned, everything is cost, which is a commercial available hardware. Everything is virtualized, everything is put into container or OpenStack, that kind of situation. So you can see we are end-to-end all the way to the end devices from cloud. This is SuperMicro product portfolio. You can see we had DU, CU, core, edge, and all the way to the cloud data center. Okay. And again, we are very happy we have all those opportunity going forward, but in the same time, it will create a lot of problem for the world. Okay. Now take a look about the IT situation today. Today, IT is consolidated into the cloud, right? Any cloud situation will be megawatts consuming the power. But not just power consumption, but also the cloud create a lot of e-waste because so many devices, after a few years, you obsolete, you toss away, and all those devices become e-waste in the world, so create problems. So you can see 3% of the global electricity supply is for the cloud, and which is a little bit bigger than the telecommunication devices. If I add together, that will be a lot. So, SuperMicro is doing resource-saving architecture for a while. The concept of resource saving is trying to reduce the power consumption and also reduce the e-waste. So we can provide customer or the market less TCO, reduce the TCO, but also reduce the TCE, which is impact to the environment. Okay, so that's the concept of the resource saving architecture. Now there are four technologies associated to this resource saving architecture. On the top, you can see disaggregate server architecture. And disaggregate means the compute, the resource, I/O, networking, all separate. When you need it, you can ask it for it. You don't need it, give it to other application. Flexible resource saving. Second is free air cooling, because today's technology from SuperMicro, you can sustain very high temperature operation. In a typical data center, 35 degrees C, 40 degrees C is very easy. And then you can sustain the high temperature, continue to operate with the full speed. No need to mention when we do the outdoor units for the antenna and the DU, that will sustain to 65 degrees C. So why not using those high temperature sustaining server inside the data center so you don't need air conditioner to save power. And pool resource, as I mentioned, the compute, storage, networking are separate. So when you need it, you can pull in. If you don't need it, you can give it to other applications. And finally, the rack scale design is for the resource management for the scale level of racks or data center. It's a software resource management. So with this technology, we can save a lot of TCO and TCE. So you can see on the chart, most of the component in the server can sustain 10 years or 15 years. We should not just toss away. Only those CPU memory we need to upgrade, and we can just upgrade those portions, and other portion can continue to use for many, many years to come. So you can see disaggregated server architecture is not just modularized server design, but also on the motherboard level, you can have different module. You can get away the CPU and memory portion when you need to upgrade. So it looks very simple, but actually it's a lot of technology inside. For example, we have to consider future 5 years, 10 years, PCI Gen 3, PCI Gen 4, PCI Gen 5 continuously, so you can continue to use it when you upgrade your CPU and memory. Okay. Free air cooling, like I mentioned, today's server can sustain very high temperature. Why using air conditioner to waste the power? So free air cooling, this is a good example of free air cooling. So in the hot aisle, you can suck in the air up top, and then using radiator, water coming in, bring the heat out to the door, and with the water tower to exchange the heat, and then water coming back. And you can see the air is contained inside the data center. There's no air pollution or humidity problems. And the water is also recycled. Cold water coming in, hot water going out, and just continue to recycle. And this operation can give you PUE 1.06. Okay? And we've been doing this for 2.5 years. One of the storage in California, and this is an Intel data center. So far, we deployed 200,000 nodes in the data center. All those numbers are based on the true number. For example, the 35% to 65% reduced CapEx, and 1.06 PUE save $4 million in a year just for the electricity bill. So those are the real number. Hopefully, maybe someday you go to California, I can bring you to the data center and check it out. Okay. Before I end it, I'd like to play a video. Although KDDI played a little bit, now I will play the whole set. Okay. Maybe you can help me. So give me some time. Which way? We're helping each other.
We once thought of Earth as a massive, powerful planet, but what we have found in more recent years is that it's actually quite small and fragile. At the same time, rapidly evolving IT infrastructure here on Earth is being felt everywhere. even helping us to see a black hole 55 million light years away for the very first time. For technology today has helped us advance both far and near. Back here at home, it's redefining how we interact with the world. 5G, one of the more recent developments of our world's technology, will enhance our lives with up to 20 times the speed of today's networks, massive capacity increase, and lower latency for time-critical applications. We experience life on demand. We are also seeing tremendous advances in artificial intelligence. Its rapid growth and sophistication, improvements in manufacturing, automation, and critical thinking span the globe, with the backbone of the server infrastructure needed to deliver this technology growing on a daily basis. However, this massive scale and growth of IT infrastructure is impacting the world we live in. This continuous cycle of forklift upgrades to the latest and greatest is partly causing higher rates of energy consumption and an increasing burden of e-waste. But to help ease this burden on our resources, SuperMicro leads the way of green computing technology. Founded over 25 years ago in Silicon Valley, we continue to grow our headquarters, engineering, and manufacturing footprint in the San Francisco Bay Area, with offices around the world. Leading the industry in first-to-market, high-performance, high-density, and energy-efficient server innovation, the SuperMicro resource-saving architecture delivers superior TCO while reducing environmental impact. The disaggregated design allows for independent upgrades of compute subsystems, reducing hardware acquisition costs by up to 38%. Extended life subsystems means reduced maintenance and longer system lifespan, up to 12 years. Resource-saving design allows for a parts refresh cycle that includes CPU memory, 3 to 5 years, network, I/O, and storage, 3 to 12 years, enclosure, power, and cooling, 12 years, optimized power and cooling with shared infrastructure for higher efficiency, and free air cooling for reduced data center support infrastructure equipment can achieve a power usage effectiveness, or PUE improvement, up to 90%. Worldwide usage of SuperMicro high-efficiency servers could save up to $7.6 billion in electricity costs, 76 billion kilowatt hours per year of electricity, or the equivalent of 7 billion trees. A data center equipped with 1,000 SuperMicro servers can save the equivalent of 590 metric tons of CO2, or the carbon sequester by 695 acres of US forest in 1 year, compared to the legacy servers in use in today's data center. Cloud computing environments allow providers to serve multiple clients, customers, or tenants through the pooling of high-value all-flash NVMe resources by eliminating over-provisioning while increasing flexibility. Combined with our rack-scale design management software, this creates a future-proof solution, providing a brighter future for our children.
Well, SuperMicro is a company with mission. I hope we can work together to help the world, to reduce the problem that technology people create, and also we make 5G green. Thank you.